When psychological researchers really want to get useful, meaningful data and results, we want to do the formal experiment. A formal experiment is the only method that can tell us something about cause and effect. One of the reasons that happens is because a formal experiment has a lot more going on. There are a lot more components, and it's much more controlled than the descriptive methods or the correlations. One of the things that helps a formal experiment show cause and effect is how we utilize the variables that are involved in a study. The independent variables are the variables that we can account for, we can change, we can manipulate, we can control, and as much as possible, we want to know what those variables are. In the example that I used in the previous video about drinking coffee before an exam, the coffee would be an independent variable, but also the amount of caffeine. When the coffee is being used before an exam, we can change the amounts, we can change the time frame. It could be 15 minutes or 5 minutes. Other variables such as whether the subjects are male or female, how much previous experience they have with the subject, IQ, how long they studied, what their socioeconomic status is. In a formal experiment, we want to try to account for as many of these independent variables as possible, and then bringing it down to one target variable, which in my example is the caffeine. Then the other variable that we look at in a formal experiment is the dependent variable. This is the measured outcome. We want to see if everything else is equal and everything is the same except for this one variable of caffeine, we're going to use those test scores to see if the caffeine made a difference. We want to see if those test scores improve, going back to scientific method and that hypothesis, that reasonable explanation of what our results might be. The other thing with a formal experiment is the groups of people that are used. We have at least 2 groups of subjects in a formal experiment. We have an experimental group that gets that target variable. Once again, in the example, the caffeine. But we want to see if the caffeine really makes a difference. So we need a comparison group. That's where the control group comes in. Everything should be the same between the experimental group and the control group, except for that one target variable, such as the caffeine. So the experimental group would get caffeine, but the genders would be the same, the IQ scores would try to be the same, the amount of experience and knowledge in the subject should be the same, everything being the same except for that one variable. Then when we go to analyze our data, once it's gathered, if there is a difference, if the experimental group did better than the control group, better than what we would expect from chance, then we know that the caffeine caused some kind of effect in the experimental group as opposed to the control group. This is where it's important to make sure that the experimental group and the control group really come from the same population and that they're randomly assigned to the control group or the experimental group so that we can better assure that they're truly representative of the sample that we're studying and that there aren't other extraneous variables, outlier variables, that we didn't account for that might explain a cause and effect that would lead to a significance error that where we would make that mistake and the results that we're seeing aren't meaningful. We want the research to be as well designed as possible so that when we get our results and we analyze them and report that information, that we're giving the most useful information